All right, here we go, boys and girls. This is assignment 6E. This is a continuation. We're going to see a lot of these approximations using those different Riemann sums. So left side, right side, midpoint, and trapezoid. So this very first question is asking us to approximate using the midpoint. So it says use the midpoint rule with n is equal to 4. That's the different, like, quote unquote, sub intervals. I'll show you what that means. So with n of 4, to approximate the area of the region bounded by the graph function and the x-axis over the interval. So here we go. Let's draw a picture to kind of understand what this is. So an ln looks like this, a line that you drop a log on. And so we want to see this from 1, which that happens to be the 1, to 5. Let me make this actually a dash. To 5. So 4 subintervals are at 2, 3, and 4. So there is intervals 1, 2, 3, and 4. 4 subintervals, and that we're going to make them equally spaced. So we see that these subintervals have lengths of 1. All right, so that is all fine and dandy. So we have these subintervals that are equally spaced. All right, because we are using the midpoint, okay, because we're using the midpoint, the heights of these rectangles are going to be the midpoint of each one of these. So that would have an x value of 1.5, 2.5, 3.5, and 4.5. So let's go ahead and use our calculator to figure out what are those values at those quote-unquote midpoints. So at 1.5, this has a value of 4.05, blah, 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 blah. At 2, okay, actually, I'm not going to get these values. I think I remember the trick to this question. All right, so this height is in essence going to be whatever the ln of 1.5 is. This height is the ln of 2.5, and the ln of 3.5, and the ln of 4.5. All right. So let's go ahead and set this up. What is the MRAM, in essence? That's what they want us to know. And so that will be a base of 1, which is going to be consistent. And then we have the ln of 1.5 plus ln of 2.5 plus the ln of 3.5 plus the ln of 4.5. Right? And so here's a double trick. If you add logs together, like if I have the ln of A plus the ln of B, that's the same thing as saying the ln of A times B. That's the same thing. Just like another trick is if I have a subtraction, then it's a division. And last but not least, if you have something multiplying an ln, okay, that's the same thing as talking about its power, or vice versa. So I know in, I'm kind of getting away from this question, I know in some questions you'll have an answer of ln of 4, okay, which is the same thing as saying the ln of 2 to the 2. So what you might see it as is ln of 2 ln of 2. These are all the same thing. All right, so in this case, one time, so this is going to be the ln of 1.5 times 2.5 times 3.5 times 4.5. Probably could take out, anyways, I'm not going to get it anymore. So the ln 1.5 times, try that one time. ln of 1.5 times 2.5 times 3.5 times 4.5. I just want to see something real quick. Okay. The fraction isn't anything good on the inside, so yeah, that is what it is. And if you don't believe it, you could go ahead and do it the long way. ln of 1.5 plus ln of 2.5 plus ln of 3.5 plus ln of 4.5. Do I lie? That's the approximated area. Again, what these were, again, I do have more color used, is these are heights at these midpoints. Okay, so here we go, estimating a definite integral. So again, as I was kind of describing in the last lesson, what it means to be, what this, okay, this is called a lower bound. And this is an upper bound. And what an integral does is this. Let's say f does, there's f, okay? Okay, f does whatever. What an integral is, this is an integral, is this is the area underneath a curve from the lower bound to the upper bound. So from 0 to 6, the area to the x-axis is what the integral is. Now, we don't know how to take that integral and find the exact area, but right now, what we know how to do is we know how to break this up, and we can approximate it in various ways. Okay, so that is kind of what we are doing in this situation. Okay, so real quickly, we're using this table, and I don't know why they put the table at the end, but they do. So we're evaluating this integral from 0 to 6 with 3 subintervals. All right, so with 3 subintervals. So that means if I'm going from 0 to 6, okay, if I'm going from 0 to 6, 3 subintervals would be at 2 and 4. Okay, 2 and 4. All right, so getting a rough idea of kind of what this thing looks like is 0 has a value of -6, 1 has a value of 0, 2 has a value of 8, 3 has a value of 18, 4 has a value of 30, again, this is obviously not drawn to scale. 5 has a value of 50, and 6 has a value of 80. Okay. So the very first question asks us to approximate this area using the left endpoints. All right, so this very first, we have most of them using these rectangles right here. Hey, also, if an area is underneath the x-axis, so for instance, the first left is going to be a rectangle underneath, this has a negative area. So this has what, a height of 6 and a base of 2. So this technically has an area of 12, right? A base of 2 and a height of 6. S has an area of 12, but because it's underneath the x-axis, this area is technically negative 12. It'll come out in the wash when you recognize the height as negative 6, but just heads up if you see it later on down the road. All right, so what does this look like? So left-hand sides are going to be the heights. So this is kind of my approximation of this. So in this situation, what is my area? So this is an LRAM. So the left-hand sides are going to be at 0, 2, and 4. 0, 2, and 4. So we have bases of 2 and heights of negative 6, 8, and 30. Because we have a consistent base on each one of those, I GCF that out, and then I can go to work. So 2 times negative 6 plus 8 plus 30. This will have so this has an approximation of 64. Okay. The next one is a RRAM. So let's go over to the picture and take a look at what that would be. So the right-hand sides are all of the heights. So the right-hand sides are all the heights. So again, we have consistent base of 2, and the right-hand sides are at 2, 4, and 6, which have heights of 8, 30, and 80. So they had a huge discrepancy in area there. Huge difference. Okay, and then we have this MRAM. Which heights are going to be at 0, 18, and 50. So the heights are determined. So if the first interval is 1 to 2, and then 2 to 4, and then 4 to 6, the heights are determined by 1, 3, and 5. So again, we still have bases of 2, but we're at 1, 3, and 5. And that's probably the closest thing to the actual answer right there. Probably. So again, if our rectangles are here, I'll just make them different heights just to kind of make a different picture. So let's go to 2, 2 to 4, 2 to 4, 4 to 6. Again, if you want the left hands, use the left hands. Okay? If you want the left hands, use the left hands. If you want the right hands, use the right hands. Oops, If you want the right hands, use the right hands. If you want the midpoints, then use the midpoints. Okay, here we want to use the trapezoid rule. Warning, warning, warning. The bases are not the same. Okay, the bases are not the same. So our intervals are going to be right here, right here, right here, right here. So each one is an interval. So notice how these intervals are different. So this has a base of 0.5 right here. This has a base of 0.25. This has a base of 0.25. This has a base of 0.5. This has a base of 2.5. And this has a base of 2.5. So notice how they're not consistent. So you can't drag out the entire thing and use the easy ways of doing it. Again, the easy way of doing it would be 1/2 height, and then it would be base 1 plus, base 1 plus 2 base 2 plus 2 base 3 plus 2 base 4 dot 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 plus 2 base whatever n minus 1 is times just a singular base n, whatever the last one is. So it's a singular, singular, and everything is doubled in between. That'd be the easy way, but you have to have a consistent height. Here we do not have a consistent height, and so we have to do it the long version. So I am going to GCF out the 1/2 portion of this. So I'll worry about that at the end, but I'm just going to write it the long version. So the first one is a long half, 1/2. And then, so I see that it has a height of 0.5, and then base 1 plus base 2 plus. The second one has a height of 0.25, base 1 plus base 2. The next one has a height of 2.5, base 1 plus base 2 plus 1/2. The height, this one is 0.5, base 1 plus base 2. Back down to 0.25, base 1 plus base 2. Last one, 2.5, base 1 plus base 2. That's a 3.14. All right. Simple as that, right? So what I'm going to do is I'm going to do all of this, and then I'm going to, I'm in essence GCFing out the 1/2, so I'll worry about the 1/2 at the very, very end. So the first one is 0.5 of 4.32 plus 4.58. Okay, plus 25 with 458 and 579. Plus 25 with 579 and 614. Okay, plus 0.5 with 614 and 764. Plus 25 with 764 and 808. Plus back to 25 again with 808 and 814. Okay, so that's all that, and then again I GCF'd out 1/2, so ultimately I have to divide by 2. So that's our trapezoidal approximation. Okay, so in essence, right now, that's how we know how to do integrals. Is the area under a curve.